Hey guys, Mr. Bowman here. In today's video, our learning objective is in blue. We are working on systems of equations, 3 variables, and the biggie for today is we're looking at how to use something called the elimination method, an algebraic method, to help us solve these 6 questions. We're going to go in an excruciating amount of detail for each of the questions so you can understand every single step, every single micro step that helps you solve these questions. To help us navigate through these questions, I'll have this 6-step process that you can see on the left-hand side of our screen. I'll have this on the screen at all times, and we'll chat about each of the steps as we navigate through our questions. So I've got question number 1 on the screen, and I'm just going to change to the green pen. And what we're going to do is we're going to start by looking at the first step, and we're going to think about the easiest variable that there is there. And in this case, it's actually going to be really easy to decide this because the y variable, we've already got the exact same number of y's in each of the 3 equations, so we don't need to do anything at all there. So we'll give that a big tick. The next one, this one's actually done for us in this question, but you're not always going to have the same amount of y's in every single question. If maybe the x's were the easiest one, we might have to manipulate the equations a little bit to make sure there's the same amount of x's in each equation. So this time around, we're going to give ourselves a tick here, but that's not always going to be the case for these questions. So we're now thinking about step number 3, and that is when we're eliminating equation number 1 with equation number 2. So let's label question number 1, or equation number 1, equation number 2, and equation number 3. And as I said, we're going to deal with the first 2 equations. Our goal initially is to eliminate the picked variable, which is the y's. So to get rid of the y's that I've circled, we need to go y minus y, which is 0. All the y's are gone. So what that means is we need to go equation number 1, and we're going to subtract all of equation number 2. That gets rid of the y's completely. The issue with this is we've got to do it with every single part of the equations. So we initially need to start off with the x's. X minus 2x is going to be negative x. We're then dealing with the y's. Remember, this is what we want to go away. Y minus y is 0, so they're gone. And then we're moving on to the z's. 3z minus z is going to be positive 2z. And equals, finally, we're going to deal with the numbers at the end. We've got 11 minus 13. That's going to get me to negative 2. And this equation here, big fan of this. I've eliminated the y, which is the picked variable. So I've now done that 3rd stage here. Moving on to stage number 4, down the very bottom, or down the middle-ish there, I now need to eliminate the picked variable from equations number 1 and 3. So same thing. So equations number 1 and equations number 3. So this one's a bit annoying because we've got to pretend that that one there in the middle doesn't work. We need to do the same elimination process. And we're dealing with y and y. So again, subtraction means y minus y is 0, and I've eliminated the y variable. So we need to do equation number 1 minus equation number 3. So even though we've done subtraction for both of these, that won't always be the case. So let's do that. So we've got x minus 3x, which is going to be negative 2x. We've then got y minus y, which is 0, and that's the goal for eliminating that picked variable. And then finally, we've got 3z minus 4z, which is going to be negative z. And that there will be equal to 11 minus 18, which is going to be negative 7. So we've now done step number 4, and unfortunately 5 and 6 is where most of the work is going to come into, and it's a bit of an art form, so you need to be able to navigate yourself through the questions. So question number 4, we need to solve for the 2 picked or non-picked variables, and in that case, it's going to be x and z. Those are the 2 equations, or the 2 letters left over in those green equations. So now that we've made these new equations, let's call that their equation number 4, and let's call that their equation number 5, just because they're a bit new. We now need to do a similar process. How can I eliminate one of the variables? And the variables both look easy this time around because we've got z and 2z and x and 2x. So what I'm going to do is I'm going to go equation number 4, and I'm going to multiply it by 2. And the goal for that is to turn that x into a 2x. which means I can then eliminate both of them together. So we're going to have negative x times 2 is negative 2x. And then we've got 2z times 2. That's going to be plus 4z. And then finally, that's going to be equal to negative 4. So we've got negative 4. So that there, because it's a new equation, let's call that equation number 6. So we're now working on these two equations here. And by subtracting the equations, we can get rid of the x's. And that's because negative 2x minus negative 2x becomes negative 2x plus 2x. And they cancel each other out, getting us to 0. So if we do equation number 5 minus equation number 6, we can cancel out those x's. So as we said, the x's cancel each other out. So we're now going to have negative z minus 4z, and that's going to be negative 5z. And after that, we're going to have negative 7 minus negative 4, which is going to be the same as negative 7 plus 4, which will be negative 3. So we've now got negative 3 over here. And a little bit of algebra, we can get rid of the negatives by going 5z equals 3. And after that, we can go divide by 5, divide by 5. Z is equal to 3 over 6, or 3 over 5 if you want to keep it as a fraction, or 0.5 if you wanted the decimal. So if we're back at our list, our goal was to solve for the two non-picked variables. We've now figured out z, but we are left with trying to figure out what x is equal to. So we had equations up here with x and z. We now have z, so we're going to put the z we know back into one of these equations, doesn't matter which one, and that will let us figure out the z. What I'm going to do, just because the x up the top looks easier, I'm going to put the z back into this equation here. So I'm going to write the equation down. So I've got negative x plus 2z equals negative 2. So that was a direct copying from above. I know that z is equal to 0.6. So what I'm going to do is I'm going to go negative x plus 2 times 0.6. So you'll see I've taken out the z and put in the 0.6. And that will be equal to positive. That actually meant to be negative sign there. So we can now simplify the multiplication. That's 1.2. So we've got negative x plus 1.2 equals negative 2. We can then do minus 1.2 minus 1.2. They cancel each other out. So we've got negative x equals negative 3.2. And because there's negative signs on both sides, we can just ignore that. X equals 3.2. And if you go back to our goal, we've now, crossing it out, we've now found the second of those two non-picked variables. And our final one down the very bottom, it's half scribbled out already, we need to calculate the picked variable, which is y. And to find y, we go back to our initial equations, and we're going to pick which equation we think is going to be easiest to calculate y. I'm thinking it's probably going to be the top one, because the numbers look nice, so let's write that down directly. So we've got x plus y plus 3z, that's equal to 11. We know what x is. Remember that x was equal to 3.2, and that was from below. And we also know that z was equal to 0.6, and again, we calculated that earlier. So we're going to substitute both of those in. So 3.2 plus y, and remember y is the letter we had as our initial eliminated variable, the one we picked, and we're going to plus 1.8, which is 3 times the 1.6, or the 0.6, and that's going to be equal to 11. We're now going to simplify that. The 3.2 and the 1.8 becomes 5, so we've got y plus 5 equals 11, and we're now going to go minus 5 minus 5, which means y is equal to 6. So wrapping this question up, therefore, x was equal to 3.2, y was equal to 6, we just calculated that, and z was the first one we calculated, and that there was equal to 0.6. So hopefully you see how that question was done. We did it through in so much detail, step by step, but hopefully it's making sense. We are now on to question number 2 up the top, and again we're going to go through our same 6 steps, and we'll go through them in a bit of detail to help us out. So first step is we're going to pick the easiest looking variable, and this one's a bit trickier. If you have a look at the z's, nothing's the same. If you have a look at the y's, again, nothing's the same. And if you have a look at the x's, it's okay because we've got these x's that are the same, but that third one's a little bit different. So in this case here, the easiest variable to eliminate is going to be that x. So we're going to put a bit of a tick there, and we've decided to get rid of x. This is going to be a new step compared to that last question. We now must ensure the picked variable has the same amount for each equation. And this time around, 3, 3, 5, they're all different. So we're going to need to do a little bit of changing. And that's why I've got this referenced here, LCM, the lowest common multiple. And what we're going to do, the lowest common multiple here is 3 times 5, which is to 15. So we need to figure out how can we get each equation to 15x. And what I can do is, if I times this first equation by 5 times 3x is going to be 15x. I can multiply the whole second equation by the same number. I'll also get 15x. And then finally, down the bottom, I can't do 5, but I can multiply it by 3. And that there will also get me to 15x's. So if I do that for all three equations, I will have 15x, 15x, 15x. And that means I've got the same amount for each of that picked variable. So let's get ahead and do that. So we're going to have equation number 1, we're going to be 15x, which is the 5 times 3. X, we're then going to have 5y plus 5z, and that there will be equal to 15. So that's our equation number 1 now. Second equation, we're going to times all the 4 parts by 5. So that's going to be 15x. And remember, that's what we want. We want the x's to have the same amount. And then we're going to have plus 10y, which was 5 times the 2y, plus 15z. 15z, which was the 3z times the 5. And then finally, we've got 30, which will be equation number 2. And that 30 was the 6 times the 5. And our last equation, timesing everything by 3 this time, not 5. So we're going to have 15x. And again, I'm liking this. All of them are now 15. Plus 21y plus 12z. And that should be equal to 33. And all of those last ones came from that chunk there times by 3. And that there is equation number 3. So I can now give this one a tick because they all have the same amount of those picked variables. We're now on to step number 3, and this is where we start eliminating it. And we're starting off with equation number 1 and equation number 2. I can get rid of the picked variable, which is the x, by going 15x minus 15x. So that means I need to subtract all of equation number 1 from equation number 2. So equation number 1 minus number 2. So 15x times minus 15x is 0. We've got 5y minus 10y, and that's going to be negative 5y. We've then got 5z minus 15z, and that's going to be negative 10z. And then finally, we've got 15 minus 30, which is going to be negative 15. Because all 3 bits of this new equation, all of them are negative, I'm now just going to change them all into positive versions. So we've got 5y plus 10z equals 15. And that's a new equation, so I'm going to call that equation number 4 now. So we've done 1 and 2. So that's a tick, and we're now going to move on to 1 and 3. So again, we're going to basically eliminate, we've gotten rid of that second one there, not interested in it at this stage. So we need to think, how can I get rid of the x's from 1 and 3? And again, it's going to be subtraction. So we're going to go equation number 1 minus equation number 3. So 15x minus x is 0, so they're gone. We've got 5y minus 21y, and that's going to be negative 16y. Dealing with the z's, we've got 5z minus 12z, so that's going to be negative 7z. And then very last one, we've got 15 minus 33 is negative 18. And like the other equation, all of these bits here are negative, which means I'm going to make them all positive to make my life a bit easier. So I've got 16y plus 7z equals 18. And I'm going to call that equation number 5 because that's a new equation. Now this step's going to be a bit annoying because this equation here, I need to think how can I eliminate some of the variables, and I can't easily subtract one from the other. So I'm going to have to yet again come up with a way to do this. And this is the step, that's a big tick, this is the step that will help me solve for the two non-picked variables. So the numbers are going to get pretty messy here. So what I did was I thought, well, 7 and 10z, I've circled them both, I can get them to 70z pretty easily. So I'm going to make sure both of them are 70z. So what that means is this equation here, I need to times it by 7. And this equation down here, I need to times it by 10. And that'll give me two equations, both of which have 70z involved. So let's do that. So we're going to have 5y times the 7 is going to be the 35y. I've then got 10z times 7, that's going to get me to 70z. And that will be equal to the 15 times the 7, which is 105. So again, a new equation, so let's call that number 6. And I now need to do the timesing by 10 to this equation here. So we've got 16y times 10, that's going to be 160y. And then I've got the 7z times the 10, that's going to be 70z plus 70z. And I just realized I wrote an x above, that's meant to be a z. And then finally we've got 18 times that 10 there. So that's going to be equals to 180. Forgive the bad 8. I'm too OCD to let that slide. There it is, 180. And we're going to call that equation number 7. So we're now down here, and we've got 70z in both of them. So we now need to think, how can I get rid of that 70z? And again, it's subtracting. So if I go equation number 6 minus equation number 7, so 6 minus 7, those 70z's are going to cancel each other out. So let's look at the y's. So we're going to go 35y minus 160y. That gets me to negative 125y. So I'm going to write that up the top there, negative 125y. 70z minus 70z, they cancel each other out, which is good. That's what we're trying to do. And that means we're left with 105 minus 180, and that gets me to negative 75. So that there will be equal to negative 75. They're both, everything in that equation is negative, so let's make them positive. So that's going to be 125y equals 75. And now we're going to do a bit of division. We're going to do divide by 125 to both sides. So y in this case will be equal to, I'm going to go straight to the decimal version because it's a bit easier, 0.6. So hurrah, I've now got my first one. I've got a whole bunch of equations here with z and y. I'm now going to put that y back into one of those equations, doesn't matter which one. Probably just pick the easiest looking one to find out what the y value or the z value is going to be. So I'm going to pick this equation here just because they're all positive. All of them have something to do with a 5, so I'm assuming the math's going to be a bit easier. So I've got 5y plus 10z equals 15. I'm now going to take away the y, put in the 0.6. So I've got 5 times 0.6 plus 10z equals 15. 5 times 0.6 is 3. Feel free to use your calculators to check that maths. So that's 3 plus 10z equals 15. We've got minus 3 minus 3. So we've got 10z equals 12. Divide by 10, divide by 10, and z is equal to 1.2. So now going back to our list, number 5, we can give that a big tick because we've solved for the two non-picked variables, which were y and z. So our last step is calculating the picked variable, which was x. So now that we're at the stage, we go back to our very original equations, and we try to pick the easiest looking one. And I think, again, it's that first equation that we're going to use. So we've got 3x plus y plus z equals 3. I'm now going to substitute in the two numbers. So I don't know what y is. So we don't know what x is, so we'll leave that as. So 3x, y, we know that is 0.6. So we're going to go plus 0.6. And remember, we calculated that up the top there. And then we're going to plus z, which is 1.2. Remembering we just calculated that. And that there is equal to 3. Now we kick into our algebra. Let's add together the 0.6 and the 1.2. So we've got 3x plus 1.2 equals 3. And now we're going to get into a bit of algebra. We're going to go minus 1.8 to both sides. So those cancel each other out, leaving us 3x equals 1.2. And we're going to divide both sides by 3. Divide by 3, which means x will be equal to 0.4. So to wrap this question up, therefore, x was equal to 0.4, y was equal to 0.6, and finally z was equal to 1.2. We are now on to question number 3. And what we're looking to do is we're going to have a bit of inspection. We're going to try to figure out what is the easiest looking variable. So this one here could go either way, but it's probably not the z's. So the z's we can rule out. The y's, maybe, I get that, because you could times the top or the bottom two equations by 2 and get 2y everywhere. But the one I like the most here is I do like the x's, because all I need to do is times that bottom one by 2 to get them all at 2x. So in this case here, the easiest looking variable, I'm going to pick variable x for that. And so we've done this step here. We now need to think about ensuring the picked variable is the same for all of the equations. And we already talked about this, but I need to multiply that bottom one by 2 to change that x to 2x. So let's get ahead and do that. So we've got 2x plus 2y plus 10z equals 681. Oh, 682. That would have been an awkward thing leading to a small math error, but there we go, that's gone. We're going to now cross out this equation because we're not really going to need that again. And we've got our new equations now. We've got equation number 1, equation number 2, and equation number 3. So let's give that a big tick. We're now going to start thinking about eliminating that picked variable, eliminating x. And we're going to start off with by 1 and 2. And focusing on the x's, 2x minus 2x is 0. So it looks like we're going to subtract these two equations. Again, I just want to note, it's not always subtraction. When you're dealing with positive things, if you have a look, almost everything's positive. You're probably going to end up subtracting a bit more than you do adding. So 2x minus 2x, as I said, is 0. That's gone. We've got 2y minus y, so that's going to be a single y. And then we've got 5z minus 3z, which is going to be 2z. Oh, sorry, I got rid of that y by mistake. So that's y plus 2z. And then finally, we're going to deal with the numbers at the end. 492 minus 344. I've already done that maths because I've got the working next to me. That came to 148. So big tick. I've eliminated the variables for 1 and 2. I now need to move on to my next step, which related eliminating them between 1 and 3. And again, we've got 2x and 2x. So we're going to be using a subtraction approach because that'll get us to 0. So let's do equation number 1 minus that equation number 3. So 2x minus 2x, as I said, is 0. And we've got 2y minus 2y is also 0. This is a bit of a bonus one, which means we're left with 5z minus 10z, negative 5z. And that will be equal to 492 minus 682, which gets us to negative 190. And I said this was a bit of a bonus because we've accidentally eliminated the y's. There's no y's there, which actually makes our life a little bit easier. So just working on this bottom equation, I can go ahead and find out the z value without needing to do some more messy algebra. So let's make them both positive. So we've got 5z equals 190. And if I go divide by 5 to both sides, I know that z will be equal to 38. So that's nice and easy. Now that I've got the answer to z, I'm going to cram it back into the previous yz question or equation that I had, and that'll let me figure out what the y value is. So jotting down the equation, I've got y is equal to y plus 2z plus 2z equals 148, and we know that z was equal to 38, so we're going to have y plus 2 times 38 is equal to 148. Y plus 76 equals 148. And this is nice. We're going to subtract 76 from both sides, which means y will be equal to 72. So I've eliminated 1 and 3, and I've also gone ahead. I've now figured out z, and I figured out y, and they were my two non-picked variables. So I'm now left with just calculating the picked variable, which is x. And remember, the picked variable, that's when I go to the very top, I pick the easiest looking equation, and I'm thinking of that second equation just because the numbers seem to be a bit smaller there. So let's jot that down. We've got 2x plus y plus 3z equals 344. I'm now going to substitute in my y and my z. So 2x plus 72 plus 3 times 38 equals 344. Let's do that maths now. So we've got 2x plus 72 plus 114, and that's equal to 344. 72 plus 114, that adds to 186. So we've got 2x plus 186 equals 344. And then we can subtract the 186 straightforward from here. So 2x equals 156, and then our final step, divide by 2, x is equal to 79. So we can now wrap up this question. Therefore, x was equal to 79, y was equal to 72, and z was equal to 38. So that wraps up this question a lot quicker than some of the other ones, and it was a bit quicker because of this step here where we accidentally eliminated the y's, and that saved us a little bit of maths. We are now on to question number 4. We're on to the grey pen. How exciting. And what we're going to do is we're going to start off with the pick the easiest looking variable step. And this time around, I'd say none of them are easy, but one of them is less annoying than the other one. So if you have a look at the x's, 7, 6, 1, all of them are completely different. The lowest common multiple, we talked about the lowest common multiple before, would have been 42. So we would be multiplying these equations by some big numbers. So that's not going to help. Y's are the one that I'm saying is the least annoying because 2 of them are 4, which means, so how I did this, 4 times 9 is equal to 36. So if I times the first 2 by 9, that means the y's become 36y. And if I times the bottom one by 4, that 9y becomes 36y. And that there will make sure all of the y's are 36y. And the z's were just a horrific idea. They were the worst of all, so we'll skip those. And I just realized I spotted a little mistake in the question. That 776 there should be 18. That was a very good spot before I got too much further into the question. So let's get into that multiplication. So we're going to start off with that top equation. We need to times all of the parts by 9. So we've got 7x times 9 is going to be 63x. We've then got the 4y times the 9. That's going to be the 36y that I was talking about. So that 36 number is really important. That'll help us cancel out. We've then got the 6z times the 9. That's going to be 54z plus 54z. And that will be equal to 776 times 9. I've already done that maths. That's 6,984. We then need to do the same for the second equation. Each of the 4 parts needs to be times by 9. I'll go a bit quicker through this one. So we're going to have 54x plus 36y again. That 36y crucial. Plus 72z. And that will be equal to also 6,984. And the final step here, we need to multiply that bottom equation by 4. And that's going to get me to 4z plus 36y. And just pausing to highlight, they're all now 36y plus 36z. And that there will be equal to 72. So I can now basically ignore these equations here. We may want to look at them later on, but they're all gone. And we're going to label these equations. There's number 1, there's number 2, and there's number 3. So the first 2 steps are done. And we're now going to think about how we can eliminate equations number 1 and 2. And again, both of them are positive, 36y, 36y. That means we're going to use a subtraction approach to help us with that question. So we're going to go equation number 1 minus equation number 2. That'll help us eliminate the y's. So let's start off with the x's. 63x minus 54x is 9x. The y's cancel each other out. That was the goal of this approach. And then we have 54z minus 72z. That's negative 18. So we've got minus 18z. And then the two numbers there, because they're the same, they're just going to cancel each other out. So that means that lot there is equal to 0. We're now going to do the same with equations number 1 and 3. So we've done 1 and 2. We're now going to do 1 and 3. So let's go 63z or 63x minus 4x is going to be 59x. The y's cancel each other out. As we mentioned, we're really keen on that. And then we've got the z's. 54 minus 32 is positive 18. So we've got positive 18z. And that there is equal to 6,984 minus the 72, which is 6,912. And that there, don't forget, was equation number 1 minus equation number 3. So based on these here, we've eliminated 1 and 3, and we're now looking to calculate the two numbers in here, x and z. So luckily this time around, we can see the z's are both 18, which means if we add these two equations together, those z's are going to cancel each other out. So let's call this equation number 4, and that there can be equation number 5. And we just mentioned 4 plus 5 will mean the z's are cancelled each other out. So what is 9x plus 59x? That's going to be 68x. As we said, the z's, they add together, they get 0. And then finally, the two numbers, that's an easy add. That gets us to 6,912. And here, this is a really nice looking equation. We're going to divide both sides by 68, which means x will be equal to, and I've got that here. And this question here, you might have thought you did a mistake, but sometimes you get decimal answers. And in this case here, I had to round it to 2dp for this answer. So it's not always going to be nice. Every question we've done to date are nice whole numbers, but don't expect that to happen in the real world. Think of money, cents, weight. All of them can be measured in decimals, and we've got one of those questions here. So I've now found x, and the other non-picked variable, because we eliminated the y's, was the z's. So let's cross out x. Now let's try to figure out what that z value is. So looking at these two questions here, that first equation definitely is simpler. So I'm going to put the x into that equation, and that'll let me figure out what z is. So we're going to go 9 times 101.65. We're going to go minus 18z, and that there will be equal to 0. I now can perform that multiplication, which I've got next to me. That comes to 914.85 minus 18z is equal to 0. I'm going to move the negative 18z to the other side, make it positive. So we've got 914.85 is equal to 18z. And then finally, we can divide both sides by 18. And that means over here, z is equal to 50.38. And that there again was a 2dp rounding. So my working wasn't perfect. Ideally, I would have liked to put it down here, but I ran out of room. So we've now got z as well. So I've got x, I've got z. I've solved the two non-picked variables. That's a tick. And now I'm looking to calculate the picked variable, which in our case was y, because we eliminated the y's to start off with. So I'm now going to go back to the very top. I need to think which is the easiest looking equation. And I think the bottom one is a clear, easier one in this case around. So let's write that down. So we've got x plus 9y plus 9z equals 18. Don't forget 18 because I did make that initial error up there. We're now going to put in both the x value, which we know. So x was equal to 101.65, and we need to put in that z value, which was equal to 50.38. So let's sub them both in. So we've got 101.65 plus 9y plus 9 times 50.38, and all of that comes to 18. So let's get the calculator out. The 101.65 plus that 9 times 50.38, that all came to 55507. So we've got 9y plus 555.07. That there is equal to 18. I'm now going to do a bit of subtraction. Let's get rid of that 555.07, subtract it from both sides. So that means 9y will be equal to, we've got 5 or negative 537.07. And then finally, our very last step, divide by 9, y is equal to negative 59.67. And again, that had a 2dp rounding. And tick, we've now calculated our picked variable. So let's wrap it up. Therefore, x was equal to 101.65. That's what we calculated first. Y was equal to negative 59.67. Calculated that last. And Z was equal to 50.38. And that was the second one we calculated. And I just want to note at this stage here, all of this had a 2dp rounding, which may have impacted the answers we manually calculated. If you put this in the graphics calculator, I imagine the answers would be very slightly different due to rounding, but they'll be pretty close to each of the numbers that we calculated there. We're just moved on to question number 5. Very exciting. We're into the purple pen. And we're going to start off by thinking about what's the easiest looking variable. And for this question here, it was a bit of a headache. There wasn't too many easy looking questions. But if you have a look, the x's, the lowest common multiple there was 35. So that's going to be messy. The y's, the lowest common multiple was 90. But thank goodness that the z's came in to save us, because that middle equation, if we times that by 3, we're going to get 3z, and that'll help us out. So our variable of choice in this case here, whoops, I've written y, but I definitely meant z. We're now going to think, so we've done that step, we're now going to think of how can we get the same variable for each equation, and we've just talked about this. We're going to multiply that middle equation by 3 to change the z into 3z, and the numbers are going to get pretty big there because of those constants at the end. So we're going to get 5x times 3, which is 15x. We're then going to have 10y times 3, so that's going to be plus 30y. We're then going to get z times 3, that's the 3z that we're looking for. And then finally, we've got the 5339 times 3, and that there is 16,017. So we've done that. We can cross that equation there because we've gone ahead and changed what we're looking for. So our equations now, so it's going to be a bit annoying, but there's equation number 1. Equation number 2 is now down the bottom because we've changed it, and equation number 3 is up the top there. So the same variables are all good because those z's, are all 3z. So that's a big tick. Now let's think about eliminating the z, because that's our chosen variable, from equations number 1 and 2. Don't forget, equation number 2 annoyingly is down the bottom because of our little tricks that we did before. And how can we get rid of the 3z's? Again, they're both positive. That means we can just do a little bit of subtraction. So we're going to go equation number 1 minus equation number 2. So let's start off with 7x minus the 15x. That's going to be negative 8x. We've got the 9y plus the 30, minus the 30y. That's going to be negative 21y. And the z's, 3z minus 3z is 0, so they cancel each other out, and that's what we're looking for. And then finally, we got 5,000 and whatever minus 16,000 or whatever. Subtracting them is going to get us a big negative number by the looks of it, and that was negative 10,034. Because all 3 parts of this equation are negative, let's make them all positive. So we've got 8x plus 21y, and that's equal to 10,034. So that there is a new equation that we formed, so let's call that equation number 4 in case we need to refer back to it. So we've now done or eliminated equations 1 and 2. So let's think about 1 and 3. So equation number 1 with 1, 3. And again, we've got z's, 3z, 3z. We can eliminate z by going equation number 1 minus equation number 2, which will be, just jot that down here, number 1 minus number 3. Let's get into that. So we've got 7x minus x, and that's going to leave us with 6x. We've then got 9y minus 5y. That's going to get us to 4y, so plus 4y. I'm liking all these because they're both positive, makes my life easier. The z's, as we talked about, they're going to cancel each other out. And I've now got the numbers, the number up the top minus the 2,805. And that gets me to 3,000, so equals 3,178. And we're going to call that equation number 5 because we've formed a new equation. So this is going to be a bit annoying because if you look at the two equations we have here, we have eliminated z, which we picked. We've now left with x and y. And that's what step number 5 is all about, is finding that those non-picked variables. And this time around, there's no easy way to get rid of the x's, and there's no easy way to get rid of the y's. So like we do up front, we've got to start thinking about our lowest common multiple, which equation is going to be easiest to deal with. And in this case, neither. But I was thinking that the 6x and the 8x, they both can be multiplied to get to 24x. So if I can get both of them to that 24x number, I can then cancel them out. So to get the 8x, I've got to multiply this one here by 3. And to get the 6x to 24, I've got to multiply that by 4. So both 8 times 3 and 6 times 4 is 24. And I can use an elimination strategy once I've got both of them to 24. So this one here is certainly going to be very challenging. So let's rejig the top one. So we've got 8x times 3, which is going to be 24x. We've got 21y times 3, that's 63y. And then we've got a big messy number. We've got 10,034 times 3, and that's going to be 30,102. So 30,102. So that there is now equation number 6 because I formed a bit of a new one. We're now going to do the timesing by 4. So I've got 6x times 4 is 24x. So 24x. And that's nice because they're both 24x now. I've now got 4y times 4. That's 16y. And then finally, I've got 3,178 times 4. And got that written down. That's 12,712. And we're going to call that equation number 7. So I'm now going to be a bit annoying, but now we're going to cancel these out because those 24s are the same. We can get rid of them. So if I go equation number 6 minus equation number 7, the x's are going to cancel each other out. We can then move on to the y's. 63y minus 16y is 47y. And then we got 30,102 minus 12,712 is 17,390. And now I've got one letter left in this equation, so I can do some division. So divide by 47, divide by 47. So y is equal to 370. So I've got my first answer. I can now think about getting the second answer, which is x. So this y needs to go back into one of those equations, which has the x and the y in. The bottom one looks like the easiest, so let's plug it into that. So writing up the top of the screen there, we've got 6x plus 4y equals 3,176. I'm now going to substitute my y in here, and that'll help me figure out the x value. So we've got 6x times 4 times 370. Oh gosh, sorry, there's only a plus there. So it's 6x plus that stuff, plus 4 times 370. That is equal to 3,178. I can now go ahead and do the timesing there, which gets me to 1,480. So we've got 6x plus 1,480 equals 3,178. We're now going to subtract that 1,480 from both sides. That means 6x will be equal to 1698, and now divide by 6, divide by 6. X in this case will be equal to 283. Again, it's one of those numbers that it's not a nice round number, so you're kind of like, oh, geez, did I do a mistake? Maybe double check your maths if you get a number like that, but if you can't see a mistake, it's probably okay, because we can expect weird and wonderful numbers as our outputs. So I've now solved, down the bottom there, number tick 5, I've now solved for both of those non-picked variables. And final step, I'm going to look at my initial equations, pick the easiest one, I'm going to find the picked variable. So these variables here, they're my initial ones, and that third equation there looks like a nice easy one to work with. So let's get into that. So we've got x plus 5y plus 3z equals 2,805. I'm now going to substitute them all in. So we've got 283 plus 5 times 370 plus 3z is equal to 2,805. This is where I get my calculator out, see what all that comes to. So that's going to be 3z plus 2,133. That's going to be equal to 2,805. I'm now going to subtract that 2,133 from both sides. So just doing that on my calculator now, we get to 600, and so 3z is equal to 672. I'm now going to go divide by 3, and we're going to get z is equal to 224. And again, a weird number. I'd probably be double checking I made any silly math errors, but just because I know the answers, it's all good. So we can wrap up this question. Therefore, x is equal to 283, y is equal to 370, and z is equal to 224. We are now onto our very last question, question number 6, and I've gone for the gold type pen. You can see it's slightly different to the yellow, but let's have an initial investigation, pick the easiest looking variable, and in this case here, it's not pretty. This is certainly the hardest one that we've looked at. If you look at the z's, the lowest common multiple will be 90, so I've got to go times 9, times 30, times 10, so that's probably a bit too messy. The y's, the lowest common multiple will be 20. So I'm going to have to go times 10, times 5, times 4. Pretty messy. And the last one there, the x's, I don't mind this one here because 8x, I can multiply 2 to get to 8, and I can multiply x to get to 8. So I'm probably going to think that x is my easiest looking variable. So done that. We now need to ensure that each of the equations have the same variable. As I said, I want to get everything multiplied to 8x. So if I times that top equation by 4, the 2x times the 4 is going to get me to 8x. And if I multiply that bottom equation by 8, the x times 8 is going to get me to 8x. And all of the equations will finish up with 8x. So let's do that. So let's start off with the first one there. I'll rush through this one a bit quicker. So we've got 8x plus 8y plus 40z equals 22,608. And we're going to call that equation number 1 now. Equation number 2, we're not doing anything with that. So let's just jot that down. 8x plus 4y plus 3z is equal to 5,161. So that's equation number 2. And then the final equation, timesing everything by 8 here. So I've got 8x plus 40y plus 72z, and that will be equal to a big number, 45,232, and that there was equation number 3. And our goal to get all of that chosen variable, picked variable, which is x, all of them are now 8x, so I can start eliminating stuff. So that one there is a big tick. Now let's eliminate 1 from 2. And because they're both positive, again, I'm going to subtract. So I've got equation number 1 minus equation number 2. So 8x minus 8x is 0, so we can ignore that. 8y minus 4y is 4y. So we'll put that down. We've got 40z minus 3z. That's going to be 37z. And then we've got the two numbers subtracting each other, and that is 17,447. So we've done 1 and 2. That's a tick. We now need to eliminate 1 and 3. And again, 8x minus 8x is 0. So I'm going to look to subtract these equations. So I've got 1 minus 3. As I said, the x's cancel each other out. We've got 8y minus 40y. That's negative 32y. We've got 40z minus 32z. That's negative 32z. And then we can subtract the numbers. That's going to be a big number. And that's 22 or negative 22,644. So we've gone through these. Let's call these equations number 4 and equations number 5 because we've done a bit of changing. And this is when we now need to solve. So we've done that. This is when we need to solve for those non-picked variables. And we've got one of those examples like, I think, question number 4. Or no, like the last question, question 5. There's no easy way to go about this one. We can't just simply cancel out the z's. Can't simply cancel out the x's. I don't want to go near the z's because 37 is a prime number. So that means it's going to get pretty messy to actually figure out that. But what I kind of like is 4y. If I times that by 8, I'm going to get to 32y. And I can cancel out the 32y's once I've done that. So what I'm looking to do, that equation there, I need to times everything by 8 to help me get a 32y. So let's start doing that. So we've got 4y times 32y. So 4y times 8 is 32y. We've now got 37z times 8, which is going to be plus 296z. So getting pretty messy. And then finally, we've got 17,000 and blah, 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 times the 8. And that there's 139,576. And that there is a new equation, so we're going to call that equation 6. And I like that because those bottom two equations, they both have that 32y part of it, so I can cancel them out. And this time around, I can cancel them out by adding. So it's, I think, the first time in this video I've actually added stuff together. I can add them together to get rid of the y's. So those y's are gone. We can now add the z's together, and that's going to get me to 264z, and that will be equal to the two numbers. Remember, we had the small minus sign there as well, and that came to 116,952. And z's by itself, so I'm going to divide both sides by 264. So z is equal to 443. So again, that's a weird number. I'll probably double check I didn't make any math errors, but I know we're all good at this stage. So this z value, we're going to substitute into the easiest looking equation with the x, or with the y and the z, and that's probably actually going to be that first equation there. So we're going to substitute that in up the top. So we might have to write small, though we'll write on the next side of the page. So we've got 4y plus 37z equals 17,447. The z gets substituted into here. So the numbers are going to get fairly messy again, but that's the nature of this question, I think. So we've got 4y plus 37 times 443, and that's equal to 17,447. I'm now going to calculate what that multiplication comes to. So 4y plus 16,391 is equal to 17447. I'm now going to do a bit of subtraction, minus that 16,391. So take away from both sides. So 4y is equal to 1,056. And then we're going to go divide by 4, divide by 4. Y is equal to 264. So I've now calculated both of those non-picked variables, leaving us just with the picked variable x to find out. So we go back to our original equations in white. Which of them looks easiest? And I'm thinking that bottom one looks the nicest. So let's jot that down. So I've got x plus 5y plus 9z is equal to 5,656. Let's sub in both the y and the z that we know. So we've got x plus 5 times 264 plus 9 times 443, and that there is equal to 5654. I now need to go ahead and calculate that multiplication. Adding them together gets me to 5,307. So x plus 5,307 is equal to 5,654. I can do a little bit of subtraction here, take that away from both sides. So x is equal to 347. Again, a weird number, like them all here. Just quickly double check you didn't make any math errors, but we are all good here. And we can wrap up this question and the video. X is equal to 347, y is equal to 264, and finally z is equal to 443. Now, I honestly don't think anyone's going to get to the end of this video. If you do, maybe just comment Snorlax, like the Pokemon Snorlax, in the comment section, just to see if anyone does. But I genuinely don't think anyone will get here for this one. If you're there, thanks so much for watching. I really, really appreciate it. Hopefully it helped. Now, we need to keep practicing.